Sorry, so I'm saying yesterday we did something on uh, how to do data entry into the software, how to do copy pasting, importing, and the manual entry. Basically, the most common way of getting data into this software will be importing. You just come to File, then import from Excel, from CSV, from any other source. We have even external sources. So it's very important to understand that. The next thing is after getting your data into this software, how do you, for example, explore your data? So today we're going to start on what you call exploratory data analysis, and it's abbreviated as EDA. Exploratory. We want to explore our data, see what we have, see what we can remove, see what we can add. So I'll make it so simple. The first thing is how to get data that is inbuilt. So we remember the other time we were taking SPSS, and we had some data sets that installed in the software. So we also have pre-installed software data. And how do we get them? Basically, it's this simple. So how to get inbuilt data sets? Thank you for reminding me. Let me do so. Can you see my screen now? So how do we get these inbuilt data sets? So we go to File. So just on your STATA, open STATA the way mine is now open. You just need to click on it once and it will open. So open STATA and come to File. So the first step is come to File. Then from File, go to Example Datasets. There is down there, navigate through Example Datasets. Then from Datasets, go to Example Datasets installed with STATA. Datasets installed with STATA. So we'll have several of them. I want just to choose one. We are going to use one. And the one that you're going to use is called, I want you to click on use. Click on use. Look at, find the one written NLSW88. Basically, it means National Longitudinal Survey for Women. These are data set that was done for women, National Longitudinal Survey for Women. And click on the button called use. So let me demonstrate that. The process is simple: how to get inbuilt dataset from STATA, how to load one, and how to now use one. So just come to File, then there is Example Datasets. Click on it. Then you can see Example Datasets. Then Description, we have Example Datasets installed with STATA, and we have STATA 15 manual datasets. So we are going to use the example datasets installed with STATA, and I'll click on Use. So we have several here, and I'll just look at them. There's auto coming down. There's this one that I want us to use called National Longitudinal Survey for Women 88, NLSW 88. Basically, that is it. And an extension for any STATA data is always .dta. So if you see anything .dta, that is an extension for what? For STATA. If you see anything XLS, XLXS, S is basically Excel. If you see anything again .csv, it can be Excel. So basically that is an extension. This is .dta. It is an extension for STATA. I want you to click use. Once you click use, click on it once, and you'll see on your variable window or your variable pane, we have variable list. So we have the variable list here. So we have several variables. Again, I said these things are movable. They're not fixed. You can drag them to see all your variables. You can move them around, and you can see You can just play around with them, make sure you can see your variables well. The next thing is, how do we explore our data? So before we go to exploring our data, another a useful command is, I want to how to comment. You can comment on STATA. So if you use an asterisk before writing any code, it is a comment. So an asterisk, what it does, basically it tells the software that whatever I'm going to write is not a code. So this is used for commenting. This is used for commenting. So this one hold for several other softwares, and it depends. Sometimes it has an hashtag, sometimes it's this asterisk. So for this software, for this specific program, it is an asterisk. So if, for example, I want to do data exploration, I can be writing notes. So comments can be notes. That is basically what I mean. So to comment, I just type an asterisk, and what we're going to do is data exploration. So data exploration. So these things are very easy, and if you repeat them, for example, let's say 5 times, then I'm sure you will have mastered almost everything. So data exploration, whatever, the first command that you can write is to see how this data is coded at the backend. You just need to write browse. So browse, you can abbreviate it as BR. Basically, Stata can allow you to abbreviate some commands and some codes. So if I write browse in short form, BR, so basically I have the data set here, and you can see this is basically it. Remember again, we talked about color codes, and anything in black is what? Numeric. Anything in black is numeric. Anything in blue is categorical. Blue means, you can see we have black, white, and other. Basically, that is what I mean. The data set is a little bit big. That's it, a little bit big. Again, it's wider. So it's long and wide at the same time. So basically, that is the first command. You can explore to see how your data. So to explore your data, you can use data. You can use browse, which is BR. We can use codebook, so that the codebook is the next one, and we can use describe. So there is also a command called describe. So describing is basically trying to explore your data. And last one, we can use what you call list. So we can list as well. So listing is a way of subsetting your data. So the next command, how do I see how my data is coded? I write the command codebook. And remember, commands are written in lowercase. All commands are written in lowercase. So if I read codebook, whatever I see is how each of the variables are. And I'm sure you're seeing something set more here, down here for you. So how do you, for example, click on that more until you're not seeing it anymore. So to set it off, so I'll comment here, to set more off, so that you get your result the way I'm getting mine. Just type the command set, commands are written in lowercase, set more off. So basically, make sure the off is double F. Something to note, set more off. Then I press enter, the code will run, and now come back to your review window and do what? Rerun the code, the command codebook, and you'll get your results as simple as this one. So codebook tells us the following. It tells us the variable type. Remember, we started by learning variable types. I hope you guys remember, we started by learning variable types. And codebook tells us the variable type, the missing. If it's numeric, it gives us the mean, the standard deviation, and the percentile. You can see for age, again, the reason why it has given us for an ID code is because it's treating ID code as what? As numeric. They are numbers. But in most cases, you can't analyze ID code, because ID codes are basically primary key. They are identifiers of specific observations, responses, and cases. So in this case, we have them as, the software does not know that this one we can't analyze this one, but it understands that this is numeric. That's why it has given us this It tells us that this is numeric. We have a range here. It starts from 1 to 5,159. We have unique values. It means we have 2,246 observations which are unique. Again, we have about the mean of this, and which is not something we can interpret. Let's go to the second observation, which is age, and age is here. So age is numeric, and we have again the range between 34 to 46. Range is basically the minimum and the maximum. So that tells you that in this data set, the youngest guy, the youngest individual is the youngest woman in this data set is 34, because this is National Longitudinal Survey for Women, NLSW8. So basically, the youngest woman in this data set is 34. The oldest is 46. Unique values have 13. The others are repeating because the age people can fall within the same age group or age brackets. So we have a mean of 39. So on average, these people are. We can talk about middle age, and we have a standard deviation of 3, and we have the percentile. So the middle person is about 59, 39 as well. So this is the median value. We have all the values unique. Okay, so let's go to race, and you can see if you do code book for race, we have race as is it has been recorded as numeric, but we have only 3 unique values. It means those after 3 they are repeating themselves. So we have a frequency table, a tabulation here. So tabulation is basically a cross tabulation. The normal one we did in SPSS, the normal one we can do in Excel, and now we can do it here as well. So if you want to see how many people, the code book will tell us how many unique values. In that time we have white, black, and other, and it gives us even the frequencies up here. So basically, if you run code book, you'll be able to see how your variables are, the types, the name, the numeric, the frequencies for categorical, and the numeric are the same measures of central tendency for what? For numeric variables. So the next one is describe. So describe, so you can write it in full. Uh, some codes you might not be able to write them in full. So describe basically tells us what? The variable name, the type, the storage type, exactly the storage type, the format display, which might not be so much important to us, and what? The label. So sometimes you get so much variables and you want to do, for example, I want to see the label for what? Maybe city. So I'll go just describe. Again, remember, even code book, you can do it for a single variable. Browse, you can do it for a single variable. For example, I can just do browse, and I want to browse just married alone. Then now see it gives me just the married. Again, it gives us a filter on the variable pen. So if I click age is added. If I click, for example, ID is added to my filter. So I can be comparing specific observations. So basically that is it. You can compare specific observation by just browsing a specific variable. You can't. It's not a must to write browse for everything. You can write browse for specific variables. So browse, and I want to browse just tenure. So basically, sorry. You see, if you make any mistake, all errors are displayed in a red color red. So basically, if you get any mistake in typing the name, that's why I insist. Just come to the other side and click on this arrow facing down. If you browse, you can browse a specific. You can do a code book for specific variables. So code book for, let's say, SMA. So this is a categorical variable where we have none and SMSA. So basically that is it. As simple as that. You can do code book for 2 variables, wage and hours. So as simple as that, I have code book for them. You can do, for example, describe for 2 variables. So describe, and I want to do describe for occupation and industry. You can now see it gives me just 2 variables, occupation, and this is basically it. The command is here. So you can describe for a specific. So again, these commands that we're using for data exploration enables us to do what we call subset our data, just looking at a section of the entire data set. You might not have enough space to look at everything, but if you use these data exploration codes, it enables us to just look at specific. The last one is what you call a list. So you can list variables. So list to list everything. Again, if you seeing more down here at the bottom here, if you're still seeing more, just type set more off. Then rerun, just click list, then rerun. Again, we can list for specific variable. So I can list variable 1 to 2, variable 1 to 5, list in. So the command is in 1, then forward slash. I want to list the first 5 variables. Can now see I've just listed the specific variables. Look at that. So here's my command, and I only list this variable. Again, list tells us how each individual question or questionnaire was responded to. So you guys have done data collection, and maybe you had a questionnaire that looks this way: ID, age, race, married, up to 10 years. So if I want to see how these variables were recorded or how they were responded to, then I can just list. So list enables us to do that. So list in enables you to subset the dataset. Then there's list in. I can list in, for example, let's say 2000 to the last one. So the last one, you can use an uppercase L. So basically, it's as simple as that. List in, then the number of observations you want to see, you separate them using a forward slash. And if you press enter, 2000, I have listed from 2000 to, that is a lot. Let me list from, let's say, 240. The last observation is the last observation is 2246. So I want to list in 2240 to the last one. So you can see now this is small that I can scroll up. Look at that. Start from 240 to what? So sometimes this one is done to do what you call back check. So if I give you maybe a job to go and do data collection, and you decide to maybe sit somewhere to cook it, I'll just list at random, and maybe if I'm collecting information like phone number or my I'm collecting things like the email, then I'll be able to basically contact a single, just choose at random and call back to check whether somebody you went somewhere where I sent you and asked some certain question and gave out some certain merchandises or motives. So basically, it's simple. List in has these three functions. You can list everything, list in 1 to 5, list in the last from specific number to the last. So it's as simple as that. Okay. So we are done how to, if you want to edit your data, you can do what? You can just write the command edit. There's a command edit, and I can be able to change these numbers. I can say this is now 38 and it accepts, but let me return it to 37 for the sake of what we're going to do. So basically that is simple. Edit mode allows you can see this now edit mode. If you do browse mode, you can't edit. This is just a browse mode. I want you to be very keen, especially when exploring your data. So assuming you want to rename a variable, I said just click on that variable. And maybe I want to rename wage as income. I'll just click on it, come to this button down here, unlock, then rename it. Rename that variable. Maybe I want to name it income. So now see it is now income, but I can just take it back to wage. You can rename a variable. So the command is rename income, the new old name. Another thing, how do you delete a variable? So how to delete a variable is as simple as the command is called drop. So if I want to drop, I can drop wage. Can now see wage is not there. I can drop several variables. So drop allows you to drop several as well. You can drop those variables. So it's as simple as that. So how do you add variables? you can edit, go to edit. Then you can now come to this other side and now add a variable. You can just add observations. It will tell you generate a variable. So to add a variable, there's a command called generate. So generate, I want to generate a variable called wage, and this wage is going to be equal to, because STATA does not allow any blank spaces, I'm going to give it a dot just to fill that place. So you can see I have a wage. The wage is blank. We have 2,256 missing values. So you can browse, you can edit, go to edit mode. Now I've added one variable, but it's blank. I can copy paste data from somewhere else. For example, this one, just highlight, then copy paste to this other side. So if you have the data from, let's say, Excel, somebody was asking, how do I add a variable? It's as simple as that. Edit, generate is the command. Then you can now paste. You can now see I've pasted almost everything. It's very simple. So you can generate a variable. There's a command called generate, then the name of the variable you want to generate. Then since STATA does not allow any blank spaces, we will take a dot to replace everything. So I want to drop it because I don't need wage. I'll drop wage. I'll drop wage. So I'll drop the command wage, the variable wage. So basically that is how to, you can add a variable, you can remove a variable. Those are the most important techniques you need to understand in STATA at this point. So let me open then a new one so that we can now do frequency. How do we run frequency for categorical variables? How do we run correlation for numeric variables? So basically that is what I want us to do in the next few minutes. So I'm going to click example file, example datasets, example datasets in Soviet data. Then I'm going to look for this national longitudinal survey for women 88. Click use, and my variable pane is filled with variables. That is an indication that the data has been loaded. So I can browse to see how the data is. I can say I have only categorical and numerical variables. Categorical being represented by blue, and numerical variables represented by what? Black. So basically that is it. And after that, I can browse. I can do a code book to see how, for example, age and race. Age and race. You can now say, can see how age and race. Age is numeric. Both are numeric, but this is categorical because we have it as white, black, and I have even the frequencies here. It's as simple as that. And the next thing you can do is you can list. If you want to list the first, list in 1 to 3. So 1 to 3, basically that. Simple. Again, you can look at how the variables were recorded. You can add a variable, you can rename by just clicking on it, unlock and rename. As simple as that. So how do we run frequencies? So my question is, how do you run frequencies? So how to run frequencies? So frequencies are, we do it for categorical variables alone. So frequency is done for categorical variables only. So how do you identify categorical variable? Just browse. Sorry, commands are written in lowercase. I have written it in uppercase. That's why I'm having an error in red. So how do I identify categorical variables? Look at the ones in blue. So anything in blue is categorical variable. It goes by default. You can even see anything in black is numeric. Anything red is string, and you can't analyze anything in red. So how do I analyze the ones in blue? So the command is simple. It's called tab. So that is what I wrote here. The command is as simple as tab. So tab, and I am going to choose variables that are categorical. Race. Look at that. So I have whatever I was getting in the spaces the same. Frequency and the percentages. So how do you explain this one? Talk about from the 2,246 women who were given questionnaires. The majority, 72.89%, were the whites, constituting about 1,637 individuals. followed by blacks, which constitute about 26, 25.6.96%. Then in brackets, 583 individuals. Then we have the minority being others, which was represented by the minority represented by others, just 1.6 1.16%, about 26 individuals. That is how to explain this table, and we did it well in SPSS. So the explanation remains. How do you do a cross tabulation? So to do a cross tabulation, so cross tabulation if is, for example, if I ask you how many whites are married. So for example, how many whites are married? How many whites are married? So how do you get that value? So we are going to do what you call a cross tabulation between two variables. So tab between race and married. Again, this is exclusively for two variables. So if I want to ask, if you now can answer this one, how many whites are married, then you'll tell me 1,150 whites are married. What about if I want percentages? There is an option to add percentages. So if I click on this one, I put a comma and I want to see between whites, black, and other, I'll do row wise. So row wise percentages. So if you write row, it gives you the percentages row wise. You can see out of 100, we can talk about this is row wise. I want them column wise. Sorry, I want them column wise. So basically, this is row wise. So if I'm comparing in terms of married and single, we have more whites who are married than the single. In terms of for black, we have more blacks who are single as compared to what. Then finally, we have others who are married as compared to a single. So it's very simple. How do I get these percentages row wise? So comparing black, white, and other. This one was comparing single and married. So to get it column wise, there is an option for column, and you get the percentages column wise. Basically, that is very simple. Where we now can say that in terms of people who are married, the whites are having the highest percentage, 79, followed by black, and this one having just 1%. That is a simple, very simple to explain. Again, look at the single, whites are leading, followed by the blacks. Yeah, and now others hold 1%. So basically, that is how to run frequency. Very simple. Tab, you just need to remember to use a table, tabulation, across tabulation. Again, how do you run descriptive statistics? Measures of central tendency. How to run measures of central tendency. So to run measures of central, the command is basically summarize. To summarize, it's the same thing I wrote here. You can abbreviate it as sum. So to abbreviate it by sum, just do that. And remember, this is done for categorical variable. Not categorical, but numerical. Things like age, something like wage. So basically, that is it. Sorry. Summarize is always double M. So just a moment, just a moment. Yeah, so I'm going to have age and wage. Let me start by age. Age. You can now see it summarizes and gives us the mean, the median, the minimum, and the maximum. Basically, that's simple. You can do it for several variables. We're just writing summarize and age. You can have wage, hours, experience, and tenure. You can have these and explain everything at once. So the one who works more hours gets about 80 hours. Maybe let's say this was weekly, not weekly, but maybe monthly. 80 hours of work monthly. The lowest is working just 1 hour. Wage, the highest is being paid 40 US dollars per hour. The lowest just getting $1 US. Total in terms of experience, somebody is having 28. Let's talk about years of experience, and the other is having 0.11. Tenure, we have somebody is having 25 and somebody is having just 0. So The same way we explain these things in SPSS is the same way we explain them here. I want to take questions if there is any question. So basic coding is not basic. So basically, assuming you want to know, so assuming you want to get now, for example, the variance, we want to get more about this data in terms of skewness, in terms of uh, the, the, the median and those other things. To get it, it's as simple as adding a command detail. So you can add command detail, comma, and an option detail. So detail, I can just abbreviate it as D. If I do that, you can now see it gives me the percentiles, the smallest, the largest, the observation, the mean, the weight. Again, this is just structured differently. That is just structured differently. I don't know whether you guys are getting what. So again, if you want to get more information about your variable in terms of getting the percentiles, in terms of getting the variance, the skewness, kurtosis, and those details, you can just you can just write the command detail and you get that. So that's very simple, very simple, very simple. For the first time, it might not look simple, but I'm sure as you go by, as you go through these maybe classes, you'll realize, oh, now these are the reason why I was doing that, basically. So I wanted to start on, I wanted to start on, I wanted to start on what we call inferential statistics by just doing correlation. So remember, correlation is done if you have numerical variable, versus a numerical variable. So correlation can either be positive or negative, strong or weak. So basically, that is as simple as that. And let me take time. Let me take just maybe a few seconds to explain what is correlation. So correlation. Sorry. So correlation can either be correlation. So these are tests of statistics. Remember how we did the notes? We have the same here. The ones we have for spaces. So then when we have numeric, numeric versus numeric. So basically, if you have numeric versus numeric variable, then the most appropriate test to run is what we call chi-square. Not chi-square, but correlation. So how do I do correlation? Correlation tells us two things. Nature correlation basically describes. So correlation describes the nature of association. Nature of association. So how does it describe? In two ways: the strength and what we call direction. So what do I mean by direction? So it can either be here, it can either be strength, weak. So this can either be weak or strong. This one can either be positive or negative. So how do I define negative or positive? So look at my screen. I'm just going to have a simple line to demonstrate that. So I'm having here. So this is 0. Then this is 0.5. So correlation runs between 0 to 0.5. So basically 0 to 1, not 0.5, 0 to 1. So we have again from this is negative 0.5, negative 0.5, then here is 1. So anything, this is negative 1, so it runs from negative 1 to 1. So anything going to this direction, anything going to this direction is what we call we have it as what? Positive. So this is positive. So this is going to be positive. So this is what I call positive. Okay? And positive, anything going to this other side is just obviously negative. So this is going to be negative, obviously negative. Okay? So the difference comes here. So anything that falls between 0 to 0.5 here, this is weak. Anything that falls between 0 to 0.5, either positive, this is what you call a weak. If I'm talking about weak correlation, then it's here. This is weak correlation. Anything, any value that is between that, any value between this point, any value, any value between this point, these points here, these points. So it starts from somewhere here up to going the other side. From here going the other side. So these are strong, what we call strong positive correlation. So it can either be strong positive or strong negative correlation. I don't know if you guys are getting what I'm talking about. So basically it can either be strong positive or strong negative. And that is how to explain correlation. So how do I do correlation? The number one thing you need to remember, it's done between what? Numerical variable. So if I browse, I am going to scroll this other side. I want to see if there is any relationship between wage and hours worked. So there is the null hypothesis that there is no relationship, and there's the alternative hypothesis that there is a relationship between the two variables. So to do correlation, I'm just going to write core, then call the two variables, wage and hours. So hours and hours. So I wanted to see if the number of hours has something to do with your wage. So you can see we are having a value that is 0.01. There is a positive because there is no negative here, but it is weak. It is between 0 to 0.5. So that is a weak positive correlation between what? There is a weak positive correlation between hours worked and your wage. So it means as long as you might be working, you might be taking too much time in the office, it doesn't translate to your wage because you might just be sitting there doing nothing. So basically, that is how simple to do correlation. The command is basically core, and you run it. Again, we talked about how do I do chi-square. Chi-square is very simple. Chi-square is between categorical variables. So identify two categorical variables. So browse. Is there a relationship between somebody's race and whether they're college graduate or not? Somebody's race and whether they are graduating from college or not. So to do chi-square, I'll just do tab. So this is chi-square. Chi-square, and chi-square is done. Chi-square is done between when both variables are categorical. Done when both variables are categorical. So in this nature, in this, for example is there a relationship between? Is there a relationship between someone's race and college graduate? So call grad. So I'm just calling call grad. So basically that is the question. So to do chi-square, I'm just going to write tab, which is table, and I use race and what? College graduate. So college grad. And there's an option for chi-square. So chi with a 2. This is the option to tell us that this is chi-square. Otherwise, if I don't put this one, I'm just going to have a cross tabulation, a normal cross tabulation. So that is it, and I'm going to have it this way. So I'm going to put that option to enable us have a chi-square value, a p-value to either reject or fail to reject a null hypothesis. Look at that. So the table above are the same. The only difference is one is now having what? Look at that. I'm having the same tables, but now one is having a Pearson chi-square, which is 0.00. So it means there's a relationship between somebody's race and somebody's uh, whether you are a college graduate or not. So look at that. Who are graduating more from college? What is the percentage? So I can do the percentages row-wise by just doing here, and I want to see. So look at majority blacks have a higher percentage graduation, not graduating. Basically, you can see 82 as compared to the whites. Yeah, so basically it's as simple as that. But now where we reject the where we reject the null hypothesis is here, where we are having a p-value, a chi-square value of 0.00. Aha. The next thing is maybe you want to do a t-test. A t-test is where we are having, we want to see is there a relationship between somebody who is married. Is there a main difference for somebody who is married and somebody who is not married in terms of their wages or in terms of their hours they work? Somebody is not married and somebody is not married. Who is married? So t-test is as simple as doing a two-factor categorical. If we have this one, we have categorical and what we call numerical. So for this case, for example, if I want to see whether there is association, is there a mean difference? Is there mean difference between in hours between married? So married, we have somebody either married or not. So this command is very simple. The command is t-test. Then the numerical variable comes first. Then I put a comma by the categorical variable married. So I want to see whether there's a mean difference. So remember how we were stating the how we are stating the what at the null and the alternative hypothesis. So you can see if you minus this one minus this, the mean for single and the mean for married, if it's zero, if the difference is equal to zero, that was our null hypothesis according to what we did. So mu1 minus mu2 is equal to zero. The alternative is that the mu1 and mu2 is not equal to zero. So this is what we are looking at, the one in the middle. So look at the mean for male, for the married, and the mean for people who are not married. It's not the same. The married, the single seems to have more hours as compared to the people who are not married, who are married actually. So we are going to reject this one. The mean is not equal to zero. So we are going with the alternative hypothesis, which is this one. So basically, that is a simple way. That is the simplest way to run t-test here. These commands are very direct. So if you're doing t-test, you just need to remember the option. If you are doing chi-square, you just need you just need to remember what the option married, the option by chi-square, option chi2. Correlation is just correlation. Summarize just for uh, measures of central tendency. Tabulate or tab is just for table or frequencies. Very simple. And lastly, how do you run a simple linear regression? So to run regression, the command is basically regress. So we want to see factors that affect somebody's wage. So I'm going to wage is our dependent, and we're going to look at factors that affect it. So simple, you start by the dependent variable, then followed by the independent, which is hours, total experience, tenure, maybe occupation, maybe college graduate. Yeah, those are maybe the factors that might be affecting somebody's wage. So wage is here. So wage is our dependent variable. These are the independent variable. Then we get just a table, just like the other one, where we have the first part, the model summary. The second table, this is the model summary. Then the ANOVA table and the coefficient table. Model summary is here. This is what the model summary, where we are looking at just the R squared. Multiply this R squared by 100%. Talk about 17% changes in somebody's wage is explained by these hours, total experience, tenure, occupation, college graduate. Talk about the overall significance, which is the p-value here. This is less than this normal significance value, telling us that this model is statistically significant. Look at the p-value. All the p-values are less than the alpha value, meaning all these variables contribute to somebody's wage. Okay. Again, to come up with that coefficient, this is the constant. If you want to come up with the regression equation, this is the constant. Then followed by now the coefficient will be x1, x2, x3, x4, x5. Again, there's a negative relationship between occupation and wage. So as one increases, the other reduces. Basically, negative relationship always talk about an inverse inverse movement relationship, where one increases, the other reduces. A positive relationship implies both goes the same direction. So that is very simple. And the last thing I'm talking about is how do you share your codes. So to save your work, we said you can just click here. I'll save the file here. To save, for example, to share with me your work, what I'll need to do is, again, you can delete these ones, the ones that are in red, because those are errors. You don't need to share anything that is having error. Just right click on it and delete. And to share these codes so that I can run them on my side, you just need to select them all, right click, and send to a do file editor. So a do file editor is this. I just need to save it and call it my do file, my do. So STATA, my let me talk about this is the last class. Let's class on STATA. I can just save it with different names. So once you save it, I can open this code. If you share with me these codes, assuming I close everything here, and I come and open my STATA, let me close everything. So I'm going not to save anything. So to open your do file editor, just come to open, or from just click this brown folder, or file then open. So file then open. Then you can see last class do STATA. So I'm going to click on it and open. So sometimes you don't see it. Make sure you check all files so that you can see all files that you can open. But at this point, I just want to find a do STATA file. I'm going just to click there and click open. So this one will open. And how do I run it? I'll just write Control A to select everything, then click on run the selection. So if I click on run the selection, let's wait and see. So I have everything. So it will just run and everything. If you go back to your STATA, you see I have everything just from whatever we have done in this class. Everything is here. We started by cross tabulation. We went to how to measures of central tendency summarize. So let me remind you on how to do that. Let me remind you how to save this do file editor. Let me remind you how to do a do file editor, because that is what you can share with somebody. So I'm going to click just open a new STATA. So assuming these are your codes. So these are the codes you've been writing all time. So these are the codes you've been writing. You can see they are here. So again, you can paste the codes here directly and run them and execute. So to do that, to do a do file editor, just right click and select everything. Just click on first, maybe just click on one code, then Control A, right click and send to a do file editor. Send to a do file editor. So once you are here, just click save, or save the file as whatever, give it a name. Then share with somebody if they want to see your do file editor, how you did the thing. So basically the essence of do file editor is very simple. The essence of do file editor is to enable you do what? To enable you make your work transparent, such that somebody can reproduce whatever you have done. You can see if I share with you that do file editor, you'll be able to reproduce everything that I did. Just right away, I'm going to share with you that do file editor, and you'll be able to see everything. If you follow with this video, then I'm sure you will have understood almost everything that you have done. Very simple. I will stop at that point unless there is any question. So tomorrow we'll go through the assignment, SPSS, and any question on state as well. Okay. Doris, is there any question? Ian and Joyce, the class has been having a diminishing return. Numbers have been reducing each day. I don't know that these things are hard, but I'm sure that for the first time they might look hard. But don't feel left out. I'm sure once you get to interact with the class recording and do them slowly, you'll understand everything. Any question? So if there is no question, I'll stop at that point. Let me upload the video and share the notes as well. So these notes are very comprehensive. They just contain almost everything. They contain everything. Look at that. Very simple. Tab, sum, correlation, chi-square is basically tab, t-test. You start with the numeric variable and then the categorical variable. Regression start with the dependent variable, then the independent variables. Var. So very basically variables. That's what I wanted to pass. So let me save this one and share with you as well. Sorry, I want to share it on downloads. So that is it. Thank you for attending. I'll share the link with you maybe in the morning because I'm sure it's big. It will upload the whole night.